the first part is going to take about an hour. I mean, the module one, we will not take too long.
Okay.
All right. So yeah, thank you for participating in the circuit core intermediary course offered by Televersity, and which will cover the architecture, protocols, and interfaces, and then the call flows. All right. So module one will be the architecture. I mean, what does the core network architecture look like? Then module two will tackle the principles, the concepts, the interfaces, the protocols. Then module three will look at the traffic cases. I mean, not all of them, but then the key ones. We will delve deeper in traffic cases in the advanced course. All right, so that is it. All right, so these are the people that put together the course, myself, all right, and my colleague, Saf. All right. By the end of this course, we expect that you should be able to describe the circuit core network architecture and explain the circuit core concepts and principles of the mobile telecom network. Explain all the interfaces and protocols of the mobile telecom network, and then you would be able to demonstrate the circuit core signaling flows of the mobile telecom network. So we are starting from module one. Okay, so module one, this is basically how the network looks like. I'm sure you are very familiar with this architecture. All right, so here we have what we call the CS network. All right, so the CS network is like the center of all networks. Everyone connects to us. Packet core connects to us. RAN connects to us. Every network that you can think of has to traverse through the circuit core network. All right, and in the circuit core network, we have like three main nodes.
Maybe before we continue, may I ask one question?
Yeah, please go ahead.
So for the 5G, do we have an interface between 5G and CS core? Is there any interface where there will be the fallback? For instance, if we have 5G and you need to make a call, a normal call.
Mr. Bonk, we are talking about I think your question is really off track, because we are talking about circuit core. We haven't even talked about 5G. Maybe you can ask me in another session, or maybe one-on-one. You can send me a text, and then I would check and respond to you. So I would want the questions to stick to what we are doing, so that we don't stay too long in the discussion. All right, so please bear with me. Let's ask questions that pertain to what we are doing here. Then we can, you understand, just to make things, because it's not really about what we are doing. I know it may be something that is going on in your mind, but I think let's do it at the right time. You can send me a message, and then I'll respond to you. Right. Okay. So we have the CS network, which is predominantly made up of two parts. Okay, we have the control plane. All right. Actually, it's three parts, but let's stick to the diagram. So we have the control plane and we have the user plane. Now in the control plane, we'll have nodes like MSCs, TSCs, GMSCs, HLRs, okay? Then in the user plane, we have our main node, which is the media gateway. There are other nodes in the user plane, but I mean, for now, we stick with the media gateway. Now, looking at this diagram, we see that this part is connected to the different parts of the the network. So here we have the RAN, okay? So
Yes.
different types of the RAN. We have the EUTRAN, which is the LTE aspect of the RAN, the GRAN, which is the GSM aspect of the RAN, and then the UTRAN, which is the UMTS aspect of the RAN. Then
Yes.
in some cases, we may have what we call the SAT RAN, talking about the aeroplane. So we have satellite networks which connects to the aeroplanes. And in the aeroplanes, you'll be able to make calls, you'll be able to browse, you'll be able to send SMS and other things. All right. But our education today is going to stick with the terrestrial communications, that is those that exist on Earth. All right. So here's the RAN, okay, the RAN part. Then we also have another type of network, which is the IMS. All right. So the IMS is a network which tries to mimic the internet. All right. So we look at services on the internet, like gaming, like streaming, like voice over IP. We look at these different services, and when we try to replicate these services in our own network. So let's take, for example, MTN Rwanda, right? MTN Rwanda has a network.
Yes.
This network may send maybe gaming packets. Subscribers may be using your network to play games, to stream YouTube and other, services. Then your CEO decides that, you know what, let us try to monetize these services on our side. First of all, to give our customers the freedom, and then also to give them the choices, to have them make choices between what we have and what is on the internet. And then also to give them faster connection to the services, because sometimes the quality of service on the internet side is really bad. All right. But you can have a guaranteed quality of service on your network. So the CEO can make that decision that why don't we have these kinds of, we have our maybe MTN stream. So MTN, our stream is MTN Rwanda stream, which is going to provide Netflix related kind of services to our customers. All right. And this is only for MTN guys. So if you are with Airtel, you may not enjoy that kind of services. The reason why you may offer that kind of service is because you are thinking of, trying to not only be a pipeline of data to the outside the internet, but then also trying to provide services, not only being a pipeline, but then a service on your network so that people can be able to, use. And nodes that exist in the IMS, we have the CSCF, we have the MRFP, and then the BGCF. Okay, now the same CS core network also connects to the PS network. All right, so here we'll have the connections towards the MME, which is over the SGS interface, and then we have the SGSN. All right, then it connects to the service network. So the service network is what we will call the VAS, or the value added service, right? So in that network, you have the SMS, you have the location services, you have the charging system, okay, you have the lawful intercept, all right, and these databases. But again, these ones, in some diagrams, you will see that they belong to the control plane. The the HLRs, the EIRs, the FNRs, and the AUCs, they fall under the control plane, all right? So basically, this is how the architecture looks like. And then we also have the transit layer, which connects to the other P elements, like what we did with Airtel Rwanda, all right? So there's a physical connection, cable connection or Ethernet connection that exists between our network, all right, and then maybe Airtel Rwanda, or even international traffic, all right? So international traffic will fall here, maybe traffic that is going to Uganda, all of them will fall under these different aspects. So this is how the network has been, disintegrated. This is broken down into different aspects, all right? And in this course, we are going to stick to this part and then here, all right? So basically, we are going to look at the different databases, the control plane nodes, and then also the user plane nodes, all right? We have a course that tackles the RAN part. We have a course that tackles the PS part. We have a course that tackles the IMS part, all right? So maybe later you can take a look at them if you would, want to know more, learn more about them. Okay, so in module 1, this is what we plan to cover. We are going to look at the introduction to the CS architecture. Under the architecture, we have 3 main layers, all right? We have the connectivity layer, we have the control layer, then we have the service layer, all right? And then under each, we have the different nodes. Okay, so these are the things that we are going to cover today. Okay, so here we are broken down the CS network, right, into its 3 main parts. The connectivity layer, which is also known as the user plane layer, the control layer, the application layer, which is also known as the service layer, all right? Now, in general, when we say what is CS network, or what is a circuit switch network, what do we mean by that? All right, so it's a type of connection, right, that is set up for the purpose of a constant flow of information. Example, voice, example, video. All right, so these kinds of connections, the expectation is that we do not go below a certain connection flow. So if my conversation is supposed to be a 64 kilobits per second, I cannot go below 64 kilobits per second. I'm given that throughout my conversation. And that is what the circuit core network is. Hello, Bon. Just a moment. Let me answer briefly this call.
It's okay, no problem.
Yeah. Hello, Sefako. I'm in a class at the moment. Wanted to find out whether you were trying to log into my account yesterday. Oh, okay. Sure. All right. Take care. All right. Thank you for the permission. All right. So here we have the circuit switch network, right? So the circuit switch network is different from the packet switch network, because the packet switch network, first of all, is a shared network. Shared in a sense that, the same resource can be shared between different people. But with CS, no, resources are not shared. If I give Bong his resources, that is for Bong. Bong is not sharing it with Peter, he's not sharing it with Yusuf. Those are the resources that are dedicated. So in the CS core network, the resources are dedicated to you. In the PS core network, the resources are shared between users. All right. And in a CS core network, we expect a constant flow of information. Example, a 64 kilobits and bandwidth allocated to the voice call. In a PS core network, it can vary. So you'll be given, depending on what you are doing, all right? So sometimes you observe your internet data usage, you see that at some point you have 64, another point you are having maybe 2 megabits per second. So you can see that it changes according to the load on the network, right? So that is the difference between the CS and then the PS, okay? CS, first of all, as you can see, has a constant flow of data. Secondly, it is dedicated to a subscriber, to a user. PS core network doesn't have a constant flow of data because it's bursty. Now, you will see that sometimes your data usage goes very, high. Another time it goes very low, Then secondly, the PS core network is what? Is shared, right? So that's the difference between, these two. Okay. Now.
So maybe if you can go on that.
Okay.
So I see you went on WCDMA.
Yeah.
So I'm wondering if when you are browsing, is there a role of media gateway in that case?
No.
Okay. You mean that when maybe you are latching on a 3G and you are going to make call, that's where the WCDMA will point on media gateway.
Okay. So, do I have a diagram? Let me see whether I have a diagram here. You've actually gone way ahead of us. You are not supposed to ask this question at this time, but not a problem. Let me see whether I have something for you here. Okay. So your question is, if you are on a call, does the same media gateway switch you between the data and then the voice? That's the question, right? Hello, is that the question?
Yes, sure. That's
okay. So the media gateway, when you look at the, I want IU, good. You see that this this diagram doesn't explain. What I want to say is that the RNC, right, has two connections. It has a connection to SGSN, which is what we call the IUPS, right? It has an interface. We connect to the SGSN, which we call the IUPS. Then we have a connection that connects to the MSC and the media gateway, which we call the IUCS. So anything that has got to do with data, right, will traverse the IUPS link. Okay. Anything that has got to do with voice will traverse the IUCS interface. So they don't mix. The RNC is intelligent to know that this traffic is CS or PS. So depending on which traffic it is, it will switch. It will send it to where it is supposed to go. You understand? So that is it for.
So when you fall on IUCS, so there will be a dedicated link for your service.
Yes.
As you say, okay.
Yeah. No, yes. So it's not that they have like 2 million IUCS links. No. In the same IUCS link, you'll be given a dedicated bandwidth. You understand? Maybe of 64 kilobits, of maybe 10 10 kilobits or 12 point something kilobits, if you are using AMR wideband or something, you'll be given a constant flow of data to handle your call. When your call is done, the resource is turned down and then given to another who will be requesting for it. You understand? But in the case of the IUPS, it is shared for everybody. Everyone is on that same IUPS link. You understand? So sometimes you will see that you have a lot of data. Another time, you have a lot of data usage. Another time you see that it differs. You understand? It's because the users are changing. Somebody came on, he's going off. In another moment, more people comes on the connection. So you see that what will be allocated to you is lower. So that is the difference.
So for the backhauls of CSCO, from run part to the core part. So if the bandwidth is the backhaul has the bandwidth which will be maybe at high data rate, that means it will have the capacity to seize or to receive many calls at a time.
Yes, you mean that if your backhaul has high capacity, it means that you can do, a lot of people can partake in that bandwidth.
Yes.
Okay. Yeah, I mean, clearly, yes. So it meaning on the flip side, if you don't have a lot of bandwidth, it means that you are going to also suffer. You are going to introduce congestion on the network. Is it okay? Is it answered?
Yes, it's clear now.
Okay. All right. So moving on along, we will start from the connectivity layer. So the connectivity layer is where you have your data transport. Okay. So here you find nodes like the media gateway. You also find nodes like the GSNs node. You find nodes like the BSCs and RNCs. You find nodes like the PRA, PABXs. All right. So these different nodes exist here. Now, one thing I would like you to notice that there is a connection from the control plane onto the connectivity layer or the user plane. And the use of the connection is for the control plane to control resources in the user plane. All right. And the name of that connection or the name of the protocol is what we call the gateway control protocol. So anytime you hear the term GCP, all right, it means that it is the protocol that controls the resources. I mean, on the user plane side, remote controlled by the MSC. So the MSC has what we call the MGCF, which is the media gateway control function. And that media gateway control function is what initiates the GCP towards the media gateway. All right. So that is it for the explanation for the connectivity layer. As I mentioned,
maybe to ask, what is the difference between the interface between MSC and media gateway MC interface and this GCP?
It's the same thing. The MC is the name of the interface.
No, okay. The protocol that in that interface
exists on the MC is the GCP. You understand?
So what is the protocol between media gateways?
That's the NB.
Okay, play the role of the name and the protocol.
Yes, so the NB is more of a RTP. It's an RTP kind of interface. All right. The MC is more is a control protocol, all right? So it's more of a signaling protocol, okay? But the RTP is a user plane, that's real-time protocol for the voice, you understand, to traverse between media gateways and between the BSCs and the media gateways, between the RNCs and then the media gateways. We good?
Yes.
Okay. All right, so the media gateway is the main node in the control plane, right? Right, which manipulates the network resources as instructed by the MSA, which I mentioned before, which is located in the control layer of the network. All right, so the media gateway can be seen at the borders of the connectivity layer, connecting the core network to the access network, right? As well as to other networks such as the PSTN and other PLMNs, right? The media gateway can also interface to the SGSN to provide support for IUPS traffic, but it's not, this part is not done nowadays, all right, because already our media gateways are overloaded, so we don't even want to have it also being used for data, transport, you understand? So that is why now we have dedicated nodes that are handling the IUPS, and then we have the IUCS traffic. Functions of the media gateway. So access switching function, all right, for carrying CS data and then CS voice and then data traffic. Packet handling, GTP, QoS handling, and then security. All right, so this will be in a case whereby.
So, sorry, for the first functionality, you're saying media gateway can carry data traffic, right?
It can, but nowadays it's not being used for that.
Because of maybe overloaded, to avoid that overloading.
Yes, because right. Already we are having challenges of our bandwidth are not enough, you understand? So that is why it has been separated. There is no need for.
But it has that functionality.
It has that functionality, yes. Clearly it has.
What the equipment in or the node in PSCO that can play the role of media gateway?
The SGSN.
SGSN.
Yeah, SGSN can clearly play the role. All right. Even nowadays, the SGSN in WCDMA is just a signaling node. It doesn't carry traffic anymore. It's only the GGSN that carries the traffic. And we call that kind of technique the 3G DT. I don't know whether you've heard that term before. 3G DT.
No.
Okay, so 3G DT means that 3G direct tunneling. So it means that I have connected directly to the GGSN from the RNC, and I'm sending voice traffic towards that. Unlike the previous case whereby every traffic has to go through the SGSN. Nowadays, things have changed. So you can make your SGSN just a signaling node, and then you can connect your RNC directly to your GGSN.
Do you have that setup here in Rwanda?
No. Yes, it's in Rwanda. Yes, you have it in Rwanda.
Okay.
Yeah, you have it. It's now. It's like this is the how do I call it? Every network deploys it. Is a no-brainer. You understand? Because that is the beginning of the LTE. The LTE, it sets the tone for the LTE network to evolve. Because in the LTE network, you have a node that purely handles signaling, and you have a node that handles the user traffic. All right. So that was what sets the tone for what we have as LTE today. Okay, so moving on access switching function for carrying CS voice and data traffic, packet handling, GTP in the case of data, if it has to carry data, QoS handling, and then security. Now, we have the media streaming.
What does QoS means here?
It means QoS, what we already know, quality of service.
Yeah, I know, but that functionality, I want to know more about that functionality in Media Gateway.
Okay, so it simply means that you are giving markings on your packets so that in a case whereby you are dropping packets, right, your packets will be given priority. So signaling has its QoS marking, traffic has its QoS marking, O&M has its QoS marking. So depending on what QoS marking is given to these different traffic cases, that will determine the priority that will be given on the PBN traffic, PBN network.
So the QoS will be defined on PBN side to know the priority of the packet, maybe.
No, the QoS will be configured on the media gateway, but then the end use is on the PBN. The PBN is the one that will know at which stage we have to drop packets, at which stage we have to allow all packets. You understand? So at the stage where
to segregate if it is signaling or data print packet that is coming, maybe to know which one will be allowed.
Yes. So which one is signaling, which one is voice, which one is data, right? You have to give markings to this different traffic case, different traffic, right? And the PBN would know, okay, so in the case of congestion, I cannot drop signaling. Signaling is the bedrock of traffic in my network. So signaling, I cannot drop it. I can drop some user traffic, but not signaling. So that is the kind of priority that you can give. All right. So two things: you give markings to the traffic in the media gateway, and then secondly, these markings are given priority. You also give P bits. We call them the P bits. I'm sure you've heard of the 10 P bits, the priority bits, to let you know that, okay, so in the case of an eventuality on the network, we are going to save our signaling traffic and then drop our user traffic. Okay, so that's it for the QoS.
Yeah.
You were there when we did the QoS.
Yes, yeah, but I was in my first days.
Oh, okay.
I wasn't aware of the QoS stuff, okay. But I saw the emails and stuff.
Okay, yeah. Because I remember you. Oh no, you. Those days you were not. I didn't see you. What I saw, like I didn't see your response on emails. It was when we're doing the PBN migrations that when I send the health check reports, then you would also do the same on your side and just to confirm. Okay, all right. So yes, we did a QoS handling, the QoS configuration on the media gateway and then the MSCs, and this is what we touched. So we touched on the DSCP and then the P bits. All right. So those are the uses of these two parameters. Whenever you talk about QoS, these are the two main things that comes up. All right. I mean, for CS core, we have media streaming. All right. So media streaming here, you have the codecs, right? You have echo cancelers, okay, to reduce the noise in the call. You have the tone handling, you have the protocol conversions, you have the announcements, all right? So all these things, they fall under what we call the media streaming. Then we have the establishment of the bearer connections with other media gateways. I mean, I think you've already asked that question. So how does the media gateway connect with other media gateways? So that is how it does it, by using what we call the NB bearer connections, all right, between these media gateways. And finally, the MSC is remote control, and the MGW is remote controlled by the MSCs using what we call the GitCP. That's the Gateway Control Protocol. All right, so that is it for media gateway. We have other.
Maybe. Is that all the function? But maybe the other you didn't mention other functionality, because if I not mistaken, media gateway has a functionality to transport SIP traffic, if I'm not mistaken. I don't know if that functionality can be also shown.
SIP traffic.
Yeah.
That is the bearer connections. So it's not SIP, it doesn't transport SIP traffic. It transports the NB and then the NB traffic. All right.
No, I mean, if maybe we want to set up SIP traffic between maybe.
And I'm telling you that it's not a SIP traffic. The SIP traffic is handled on the control plane. All right. SIP traffic exists, but
the media of
SIP, yes. So that's the bearer, that still falls under the bearer connections. Because the SIP network or the IMS network or the SBC has a media gateway. Okay, so you can have a connection between the CS media gateway and then the IM media gateway, which gives us the interface we call the NB. So between NBS, NB. So between media, CS media gateways, we have what we call the NB. All right, Nairobi byte. And then between a CS media gateway and an IM media gateway, we have what we call the MB. That is master byte. You understand? So that is the difference. But all of them fall under what we call the bearer connection.
So if I get you correctly, there will be the connection between SBC and media gateway. That can allow SIP media to.
Or between what we call, if you have what we call an MRS in your network. An MRS is a type of